Good morning! Today I'm going to be showing you a video that I made many years ago. I made it with Windows Movie Maker. And during the course of that video I'm going to show you some very basic conversions, but I'll do them right along with you, so you don't need to be worried about any of that. We'll treat this as a review, as a final step with speed and velocity that we've been studying for the past 20 or so days, and then we're going to switch gears later this week into something completely different, starting on Wednesday. So, without further ado, let's go. So today we're going to actually start talking about real physics. We're going to start chapter 3, section 1. Okay? Good. Now before we start all of this velocity stuff, we need to know a couple of things. First is frame of reference. Frame of reference is not a big deal. It basically means that you are watching the action, from some place. You're sitting in the classroom in school, and you're watching all this stuff unfold in a different place. You're not in the car, you're not on the highway, you're not near where the stuff is happening. Understand position, because you guys all use that word all the time, but what's the actual technical definition in physics? Is if you picture an x and y axes, you just have y axis, x axis, and picture yourself standing at the origin. The position of one dot, say it's like at 1, 1 or 1, 2 or something, the position of one dot is in relationship to the origin where you're standing. Then you can have a second dot, say it's at 3, 3. Then the position of that dot is in reference to where you're standing at the origin again, 3, 3. But the distance between those two dots has very little to do with where you're standing. You could be standing on a different part of the graph, but it would still be the same distance between the 2 points. Kind of like right now, you're sitting in the classroom watching this. The distance from you in the classroom to me in the car, and you in the classroom to Boston, has very little to do with the distance from me to Boston. That's it.
Now the other thing you need to know about is distance. Distance is as simple as it sounds. It's the distance from here to Boston. It's the distance from here to that car that just passed me. It's the distance from where I'm at now, which is 24 minutes of driving, to where I'm going to be 10 minutes from now, how far that distance is going to be. So that's all distance is.
So we just stopped at a gas station to gas up, and the computer's telling me, a bit out of focus, that we've gone 25 miles so far. So we started at 0 miles when I reset this thing, and then we've gone 25 miles now. So obviously our distance is 25 miles from where we started, and let's find out what that is in kilometers and meters, if you please. So total, we've probably gone about 25 miles, exactly 25 miles. So 25 minus 0, where we started from, is 25 miles. Nada. But the 25 miles, if you convert it to kilometers, you should have gotten about... Hey, 2020 Lishka back with you. 2008, I think it's 2008. 2008, Lishka asked you guys to convert 25 miles of distance. So distance is going to be 25 miles to, I believe I said meters and kilometers. Kilometers and meters. So 25 miles, what is that in kilometers and meters? So kilometers, question mark, and meters, question mark. And when you pause the video, which of course you pause the video, right? When you pause the video, it told you that 1 mile has exactly 1.609 kilometers in it, 1.6. And then 1 mile also has 1,609 meters in it. Really easy conversion. If you guys know anything about running track, oh great, that's a really bad. If you know about running track, how many times do you have to go around the track to do 1 mile? 4. And 4 times around the track means that it gets you up to 1,600 meters. So 1,600 divided by 4 is 400, and once around the track out back of the school is 400 meters. So this tells you right off the bat that 1,600 meters is a 1 mile run. So anybody who runs track knows this. If you don't, now you do. All right, so the conversion, let's do it. 25 miles to kilometers. So here's what you would do. 25 miles, and I've showed you guys, I've shown a couple people this before. I don't know which, like, if every class. Cool silhouette. I've shown a few people, but 25 miles converted to kilometers is no big deal. You do 25 miles, you do time symbol, and then you do a fraction bar, and then on the bottom you put the thing you're trying to get rid of, and on the top you put the thing you're trying to go to, which is kilometers, and then you put the relationship between them. And I already wrote that over here, so all you gotta do is 1 mile is 1.609 kilometers. And when you multiply those two together, you get just over 40.225. So 40.225 kilometers. You still see over there? Meh, not great, not terrible. 40.225 kilometers. And because the metric system is so easy to use, to convert 40.225 kilometers to meters is a joke. You just have to move the decimal place over to the right 3 times, because there's 1,000 meters in a kilometer. This kilo means 1,000, so you get 40,225 meters in this distance, equal to 25 miles. So you want a little bit of this, and a little bit of this for the answer. There you go. There you go, one more shot of that screen. I just adjusted everything, the lighting and the tripod. This lockdown continues. I'm going to build a studio for this, but for now, you'll have to deal with my dry erase board in my workshop a little bit longer. Back to the video. About 40.2 with the conversion factor, and 40 kilometers, as you know, is 40,000 meters. So that's what you should have gotten.
Wherever you go, whatever you do, my heart belongs to you. Wherever you go, whatever you do, my heart belongs to you. Wherever you go,
So the next thing that we got to learn about is average velocity. Average velocity is defined as change in distance over change in time. And the change in distance is simply d2 minus d1, which means some distance later on. Like right now, I'm at 38 miles, and some distance earlier, like when I was at the gas station, it was 25 miles, I think. And then it's over the change in time. Now, currently, we are at 51 minutes. So T2 would be 51, and T1 would be 31 or 32 minutes or whatever it was at the gas station. So using that, those two distances, if you subtract them, and also if you subtract the 2 times, then you will get an average velocity for my driving between the gas station and between the toll plaza, which I'm going through right now to get into Boston. And we're back. So I am going over average velocity in this particular clip. I specified in the video that average velocity is change in distance. Don't forget the little pyramids, deltas mean change. So change in distance over change in time. And if you want to get really deep into it, the average velocity is equal to change in distance, which means some later distance and some earlier distance, d2 minus d1. That's the change. Change is always a subtraction. And then the change in time would be some later time, subtract from that some earlier time. I want to get a little bit more technical, so I just want to show you guys how it can get a little bit more interesting. So, where are we going to go from there? Well, in the video, I asked you guys to get the average velocity between these two locations. By the way, side note, are you picking up on how many times I've said distance instead of displacement? That D should be displacement, not distance. This is just another in a long series of blunders I made very early on in my teaching career. Different blunders. I still make blunders, but just different ones. So, change in distance. I said that the Weston Tolls, the Weston Toll Plaza, as you're going into Boston on the Mass Pike, is at 38 miles. And I said at the gas station that we had 25 miles of driving under our belts. And then we had time. This is in minutes, so careful with the units here. 51 minutes at the toll plaza, MIN, minus 31 minutes at the gas station. So we're going to take those two very quickly, subtract them. 38 minus 25 is going to give you 13 miles of driving. Drove 13 miles between 25 and 38. And then 51 minutes minus 31 minutes is equal to 20 minutes. Now, hopefully some of you guys are already seeing an issue that I'm going to get miles per minute if I do this math. I don't want to do that. That's annoying. It's complicated. It's going to make us do more work. So I'm going to do a little bit of a trick here. Instead of 13 miles, let me move down here. Instead of doing 13 miles over 20 minutes, since the 20 minutes worked out so nicely, I can just convert that real quick to hours. And 20 minutes is how much of an hour? It's about a third. So if you just do 0.3 threes, because you know this goes on forever, it's repeating. So if you just do 0.333 hours, your math will just come out so much nicer. Also, the division makes it a lot easier because 13 divided by a third means it's going to be 3 times that. So 3 times 13 is 39 if my brain's working correctly. 3 times 10 is 30, 3 times 3 is 9, so 39 miles per hour. So my average velocity between those 2 points is 39 miles per hour. I also asked you guys to convert this to kilometers per hour and meters per second. So let me show you how to do that real quick. 39 miles per hour, just write it. Miles. In this case, I'm going to write it over hours like this to make it simpler to work with. Times bar. I'm going to write miles down here because I eventually want to cancel it. And I want to go from miles to kilometers. And hours is another one I got to deal with. So I got to make another fraction symbol. And nope. I don't need to because it's already in hours. Why would I need to convert that? That's just silly. Come on. So it's all set. All you got to do is convert the miles to kilometers and you're good to go. And you'll get your kilometers per hour that you want. Don't forget that you have a 1.609 kilometers in every mile. So that means miles cancels with miles and you get kilometers per hour like you want. And 39 times 1.609 is 62.75. So 62.75 kilometers per hour, like that. 62.75 kilometers per hour is the speed in km per h. There's one more question on here. I asked you to convert this to meters per second, and I'm going to show you that once I erase this and make some room. So, abracadabra, poof! Ta-da! So you're being asked to convert 62.75 kilometers per hour to meters per second, and now you can see we got to change kilometers to meters and hours to seconds. This is the type of problem that I'm sure a lot of you guys in their brains are already like, I don't even want to do this. Bear it with me, because conversions are not complicated once you figure out the system. It's really simple. Take it from someone who used to fear them as well. Believe it or not, I really did. Okay. Back in elementary school, my lowest 2 grades on my report card every time were handwriting and problem solving, believe it or not. So you can achieve your dreams. My handwriting is still not great, but problem solving got a bit better. So 62.75 kilometers per hour to meters per second. First, step 1, just write the thing you have. And write it like this, 62.75 kilometers per hour. It's going to help you in the long run. Now you got to do all the fraction symbols to convert. I'm going to work with the distance first, because that's the easiest. Kilometers up here, which means this fraction is going to have kilometers down here and meters up there. And all you got to do is figure out what the relationship is between them. And it turns out it's 1,000 meters every 1 kilometer. Use Alexa, use Google, whatever you want for that. I'm not going to make you ever memorize something like that. But once you use it enough, you'll actually be able to memorize it and not have to keep looking for stuff and be more lazy. So, kilometers cancels with kilometers, and we already have the meters that we're looking for. Now we got to convert that hours to seconds. I'm going to make another fraction symbol. Hours is on the bottom, so I want to get it up on top. And I want to go to seconds. The thing is, well, yeah, I'll do one step. I'll do one step, and hopefully you guys are okay with that, because otherwise I have to do 2 more of these fraction symbols. I want to go from hours to seconds. What is the relationship between hours and seconds? How many seconds in an hour? Well, there's 60 seconds in a minute, and there's 60 minutes in an hour. So 1 hour turns out to have 3,600 seconds. It's 60 times 60. 6 times 6 is 36, plus a couple of zeros, and you get 3,600 seconds in an hour. So that is what is up there. Hours ends up canceling with hours, and you're left with the seconds you want. So now what do you have to do? You have your whole formula here. It looks like a mess, but it's actually just telling you that the numerator is 62.75 times 1,000, and it's telling you the denominator is simply 3,600, because it's 1 times 1 times 1 times 3,600, because this is obviously 1 hour. So you wind up with 62.75 times 1,000 gives you 62,750, and it's over 3,600. And you just have to plug that into a calculator. You can actually do this if you want to make it even simpler. And the answer is about 17.43 meters every second. So you're covering 17.43 meter sticks every second. Does that make sense? 1 Mississippi, you've covered 17 meter sticks. Yeah, I could see that as being 62 kilometers per hour, or 40, whatever it was, 40 something miles per hour. And that's what's up. Back to the video. So we just got here, and we're in the parking garage over behind the aquarium area, and it's taken us 1 hour and 20 minutes to get here, and in that time we have gone a total of 46 miles. So figure out what our average velocity was. The last question in the video asks you for these average velocity calculations, the average velocity between our house and all the way to Boston, and the average velocity between the gas station we stopped at in Framingham and Boston. I'm going to go through these very quickly because I think we've done enough background work at this point. So, first up, the order. The order is pretty important. If you do miles per hour here first, I think that's the easiest. Switching to kilometers per hour is pretty easy because then you just have to multiply it by 1.609. And then if you get to meters per second, you will, I'll teach you guys a trick that's really, really fast to go between kilometers per hour and meters per second. I'm not going to show you the proof of it, so without further ado, here we go. Your average velocity from home to Boston is going to be the change in distance over the change in time. The change in distance is 52 miles. The change in time is 1 hour and 20 minutes. I'm immediately going to change that to hours altogether because it'll make life easier. And your time is 1.33 hours. If you multiply that out, you will get an answer of 39 miles per hour average speed. 1 down, 5 to go. How do you convert that to kilometers per hour? Multiply that 39 miles per hour by 1.609, which is how many kilometers there are in a single mile, and you will get the answer for kilometers per hour, which is about 62.7 kilometers per hour. Last thing is to convert kilometers per hour to meters per second. So here's the promised shortcut. Ready? You take 62.7 kilometers per hour and you divide it by 3.6. That's it. 3.6. It has to do with the fact that there's 1,000 meters in a kilometer and that there's 3,600 seconds in an hour, and it works out that the conversion factor is 3.6. So you do 62.7 divided by 3.6 and you get about 17.4 meters per second. And that is dunzo for that side, and you're good to go. Other side, V is equal to D divided by T. Your amount of miles between these two is going to be 52 minus 25. Your amount of time is going to be a total of 80 minutes, right? Because 1 hour is 60 minutes and 20 minutes, so 60 plus 20 is 80 minutes, and minus 31 minutes. So a little bit more interesting here. This is miles, this is miles. Okay. 52 minus 25 is going to give you 27 miles. And 80 minutes minus 31 minutes is going to give you 49 minutes. 49 minutes. 27 divided by 49 is going to give you 0.55 miles every minute. But we want that in miles per hour, so how do you convert that? Same as every other conversion problem I've shown you today. You're going to want to write it 0.55 miles over minutes. We want to get rid of that minutes, so it's going to go up top. We want to go to hours. There are 60 minutes in 1 hour. And if you multiply 0.55 times 60, you get 33 miles per hour, which makes sense. By the way, if those numbers seem low, realize that your average speed is always much lower than the speed limit because you are stuck in traffic, you're taking exits, you're stopping at red lights. So your average speeds actually come out to be quite a bit lower than you would think. All the more impressive when you hear about a race where they maintain average speeds of over 120 miles an hour. That's your miles per hour. As before, if you multiply this by 1.609, you get the answer in kilometers per hour. In this case, the answer is 53.1-ish kilometers per hour. So easy there. And if we use our trick that I showed you guys a second ago, 53.1 kilometers per hour is equal to, if you divide it by 3.6, you get about 14.7 meters per second. That is all the calculations your little hearts could possibly desire. Good board usage too. We are done. Okay, back to the video. Let's finish her off. So you figured out the average velocity, and now I just have one last question for you, which is average velocity a good measure to use in the real world? Does it make any sense, and what do you think about it? So the last thing I did was ask you guys a question about average velocity. What do you think about it as a good measure of stuff and things? It depends. As always, very annoyingly, it depends in this class. It depends on what you're trying to measure. So if you're trying to measure accurately, I don't know, the speeds between two rest stops, it works out pretty well, the average speed between two rest stops. But I mean, to say that I wasn't driving 33 miles per hour all the way to Boston, that's a bad idea on the Mass Pike where everybody's averaging 65 to 75 miles an hour at least. So it's not a very good measure for certain situations. What you want there is not average velocity, but something called instantaneous velocity. Instantaneous velocity. Instantaneous velocity. And that's how much faster you're going at that moment, and that is what you see when you guys look down at the speedometer on your gauge cluster, and that is instantaneous. If you cycle through the computer a little bit on your car, you'll notice it does usually show you average velocity too. We don't really use that one very often in the car. We're much more interested in the speedometer and fuel consumption. So in the day-to-day life, you don't really use average velocity very much, but it can be very interesting. And I'll leave it there for now. Thanks for watching. Hope your heads aren't spinning too much from all the math. I will see you next time. High five! little over 40 kilometers to equal that amount of 20. So we went 25 miles, 25 minus 0, and is the position. You're positioning. No, it sucks. No, it sucks.
Thank you for watching.